second point is the potential energy diagram. So this is our potential energy diagram versus reaction coordinate. Reaction coordinate means percent conversion of reactant to product. That is called reaction coordinate. Kotora transfer holo, product conversion holo. That is called reaction coordinate. And the energy diagram looks like this. And this is our energy barrier, potential energy barrier, and this is the product. And this is the here it is alkyl halide. So this is the potential energy diagram. So here one thing is to be noted first. Only one peak is observed because transition state has no real existence. That's why only one peak is observed. In SN1, you can remember there are two peaks because transition state is stable carbocation and has real existence, can be identified by spectroscopic method. And that's why there are two peaks. Here only one peak. And now in point number 2, we will consider different halides. If we consider different halides, so nature of the curve looks like this. This is for tertiary halide. This is for secondary halide. And this is for primary halide. This is the nature of the potential energy diagram for three different halides, tertiary, secondary, and primary. You can see the energy barrier steadily decreases from tertiary to primary. Primary is the energy diagram, energy barrier is the least found. Here you can write down in a reaction rate or energy barrier. That is because the reaction rate depends on energy barrier. Lower the energy barrier, higher the reaction rate. So reaction rate or energy barrier depends on stability of transition state. Depends on stability of transition state. So next line Lego, 5 groups are attached to the carbon atom. You can see, have a look on transition state. 5 groups are attached on carbon atom. So steric factor plays an important role. So steric factor plays an important role. And naturally, what is happening in case of tertiary halide, steric strain is maximum with highest energy barrier. This is very obvious reason. Tertiary halides energy barrier is the steric strain is maximum with highest energy barrier. While in case of primary halide, steric strain is minimum with lowest energy barrier. Primary halides steric strain is minimum with lowest energy barrier. Tertiary halide steric strain is maximum with highest energy barrier, and in case of primary one, steric strain is minimum with lowest energy barrier. Now you conclude like this. All primary halides follow SN2 mechanism. Due to obvious reason, energy barrier is minimum. All primary halides follow SN2 mechanism, comma, few secondary halides follow SN2. Few secondary, not all, because energy barrier now it is highest. So few secondary halides follow SN2, and tertiary halides never undergo SN2. Tertiary halides never undergo SN2. Sutarang, this is the conclusion we can have from this diagram. ঠিক আছে, এবারে এখনো পয়েন্ট নাম্বার 2টা শেষ হয়নি। So next point write down, next point na, next line write down. However, some primary halides, follow SN1 due to large steric strain in SN2 mechanism. Some primary halides follow SN1 due to large steric strain created in SN2 mechanism. Large steric strain created or generated in SN2 mechanism. Now, one example to illustrate which type of primary halides follow SN1 as they are experiencing high steric strain in SN2 mechanism. That's why they are following SN1 rather than SN2. Let's see this is tertiary butyl group. This is tertiary butyl, and it is connected to CH2. And this tertiary butyl and CH2, this group collectively called neopentyl group. 5 carbon atoms. That's why this pentyl, neopentyl group. Neopentyl group. Only this one is tertiary butyl connected to CH2 means this total group is called neopentyl group. This neopentyl bromide, this is a primary halide. You can see CH2Br. CH2Br means primary halide. But it does not follow SN2 due to this large size of tertiary butyl group, which does not allow nucleophile to attack on this carbon atom. It does not give any room for nucleophile to attack on this carbon atom. And that's why it has no other option but to follow SN1 mechanism. Of course, here this is SN1 in presence of, say, water as nucleophile. Water as a nucleophile. So first, this is according to SN1, we know this is the product is this. This is carbocation is formed, and of course this primary carbocation that is unstable, so naturally it is converted to stable carbocation with the shifting of Me group, and here is the carbocation CH2Me, and now H2O, there's a nucleophile attack on this water, the nucleophile forming the alcohol. Nucleophile may also attack on this. This is called this is primary alcohol is formed, and here it is tertiary alcohol. This is tertiary alcohol. So which appears as major product, and primary alcohol appears as the minor product. So rearrangement always occurs, as we know, in SN1 mechanism. So rearrangement occurs in the transition state, and ultimately this tertiary alcohol appears as the major product. So this is happening, this type of compounds where significant steric strain is generated in the transition state of SN2 mechanism. And that's why energy barrier is very high, and that's and corresponding SN1 energy barrier is lower, and that's why it follows SN1 rather than SN2. So this is our point number 2. এটা হয়ে গেছে completed?
Hello sir. আপনার বোর্ডটা একটু হেজি আসছে।
হ্যাঁ,
আপনার বোর্ডটা একটু হেজি আসছে।
বোর্ডটা কি হেজি আসছে?
হ্যাঁ স্যার।
বাকিরাও কি তাই দেখছো, হেজি দেখছো?
হ্যাঁ স্যার, হ্যাঁ স্যার।
Yes sir.
আচ্ছা, তাহলে আমি চেঞ্জিং দ্য নেটওয়ার্ক, লেটস সি। Just a minute. নেটওয়ার্কটা চেঞ্জ করে দিলাম, দেখো কিছু পরিষ্কার আসছে কিনা। Is it somewhat clear now?
Yes sir. Yes sir.
Okay. So now we will discuss point number 3. এটা হয়ে গেছে তো? Is it completed? Point number 3 তে আমরা দেখে নিই। Point number 3, number 1, A, nucleophile. So here you write down strong nucleophile always favors SN2 mechanism. Strong nucleophile always favors SN2 mechanism. So, an example theory how it is following SN2 mechanism in presence of strong nucleophile, using the same example that I have written earlier, that is neopentyl bromide. Neopentyl bromide. This is I have used water as nucleophile in the earlier example. Water is a weak nucleophile, but here if we use a strong nucleophile like say ETO minus. ETO minus means C2H5O minus. If we use this nucleophile, it's a strong nucleophile, then it will cross the energy barrier easily in presence of strong nucleophile. Then it will not allow the formation of carbocation. It will anyhow it will attack this carbon atom and forming this compound, only this compound, that is ETO, and here it is the CH2, and this is ETO, and this is Br, and here it is tertiary butyl group, forming the product, only one product, That is this one. So this is the product. In presence of strong nucleophile, same substrate, it will give SN, that is the SN1 mechanism, it will follow SN1 mechanism in presence of weak nucleophile due to the steric strain.
Sir, CH2 কি লেখা? CH2 উপর কি লেখা?
CH2 over tertiary butyl, this one, এটা.
আচ্ছা।
This is tertiary butyl. Tertiary butyl. ঠিক আছে? এটা tertiary butyl. So the same substrate molecule, when it is treated with a strong nucleophile, then it follows SN2. Energy barrier is then crossed. So this is the effect of nucleophile. Strong nucleophile favors SN2 mechanism. And then number 2, solvent. Solvent, here you write down aprotic solvents. Aprotic solvents means dimethyl formamide. That means this one. That is 2 active hydrogens of nitrogen are replaced by this methyl group. Now it has no active hydrogen to form hydrogen bond. So this is called aprotic solvent. Say then one more example is dimethyl sulfoxide. So here also these are polar, sufficiently polar, but it has no active hydrogen. This is called DMSO, dimethyl sulfoxide. So these are called aprotic solvent, but polar. So polar aprotic solvents always favor SN2 mechanism. এখন কথা হলো, why protic solvent usually not favors SN2 mechanism? তার answer হচ্ছে protic solvent deactivates the base. Protic solvent means water, active hydrogen, ammonia, alcohol, etc. These are the protic solvents. So protic solvent always deactivates the base through and that's why protic solvent does not favor SN2 mechanism. ঠিক আছে? The activity of nucleophilic character, that is nucleophilic character is sufficiently reduced through the formation of hydrogen bonding. ঠিক আছে?
Okay, sir.
And C point here say living group. So here you write down weak living group. Weak living group মানে হচ্ছে that is bond between carbon and Y. This is a very strong bond. This is very difficult to be broken. That is called weak nucleophile. So weak living group. So weak living group always favors SN2 mechanism. যদি আমরা এখানে CI যদি নিই, it will usually favor SN1 mechanism because CI bond is weak. It is easily dissociated to I minus and carbocation, and that's why it will follow SN1 mechanism. But if we use the CF or CCl like this, then the leaving group is comparatively weak, and then it is difficult to be broken Cl minus and R plus. And then a nucleophile has enough time to attack from the backside. So then, before breaking this bond, nucleophile can attack from the backside on the carbon atom. So SN2 mechanism is favored. That's why a weak leaving group always favors SN2 mechanism. So these are the this is the point number 3 under a 3. Then point number 4. Point number 4 in SN2 mechanism, only one product is formed. Only one product is formed with inversion of configuration. With inversion of configuration. And that is OH minus plus say this is R1, R2, say this is H, and say this is bromine. Then in the transition state, it will attack from the back side. That's why the configuration is changed. And finally, then it is converted to product like this. So inversion of configuration is observed, and that's why only one product is obtained. Only one product. There is no question of rearrangement in the transition state. So only one product is obtained. So this is our point number 4. And then point number 5 is optical inversion. So here you write down optical inversion and in SN2 mechanism, inversion of configuration occurs. In SN2 mechanism, as we have seen, inversion of configuration is observed. So, when an optically active compound, like this one, say this one, optically active compound undergoes SN2 mechanism, optically active compound undergoes SN2 mechanism, nature of optical activity is changed. Nature of optical activity is changed. One example is this one, already given.
Sir, so when an optically active
compound undergoes SN2 mechanism, nature of optical behavior is changed. That is, dextrorotatory when undergoes SN2 mechanism, levorotatory product is obtained. Or levorotatory compound when undergoes SN2 mechanism, dextrorotatory product is obtained. যেমন in this case, আগের এক্সাম্পলটা এখানটায় লেফট হ্যান্ড সাইডে H যদি আমরা দিয়ে দিই, সাপোজ দিস ইজ প্লাস dextrorotatory, this compound, লেফট হ্যান্ড সাইডে H হচ্ছে dextrorotatory, ফর এক্সাম্পল। তাহলে পরে জিনিসটা এরকম দাঁড়াবে, so when it attacks, then this one is H, this one is R1, and this one is bromine, and finally the product is this. So now H is on the right hand side, suppose it is minus. লেফট হ্যান্ড সাইড বলেই প্লাস থাকবে তার কোনো মানে নেই। আমি বলছি সাপোজ ইট ইজ প্লাস, লেফট হ্যান্ড সাইডে এটা আছে, সাপোজ ইট rotates pen polarized light in clockwise direction, it is plus. But after reaction with OH minus, the product is this alcohol, which is again optically active, but the directional rotation is changed in anti-clockwise direction because H is moved to right hand side. So the nature of optical behavior is changed during this SN2 mechanism. So these are the 5 major characteristics of SN2.
স্যার 5 নম্বর পয়েন্টের হেডিংটা কি বললেন?
Optical inversion.
ওকে স্যার।
এখানে MCQ থাকবে, which one of the following mechanism is related to optical inversion? তার মধ্যে অনেকগুলো থাকবে, SN2 is the right answer. SN2 is related to optical inversion. ঠিক আছে? আচ্ছা, তারপরে হয়তো এরকম থাকবে, which of the following gives only one product, following mechanism? সেটা হচ্ছে SN2 is the answer. SN2 mechanism proceed করা মানে হচ্ছে there will be only one product. মাল্টিপল প্রোডাক্ট হলে SN1 চলে যাবে। ঠিক আছে? আচ্ছা, নেক্সট আসছে যেটা, সেটা হচ্ছে SNI মেকানিজম। SNI মেকানিজম। আচ্ছা, SNI করার আগে আমরা একটুখানি দেখে নিই সাবস্টিটিউশনের দু একটা জিনিস করে নিই, তারপরে উইল মুভ টু SNI। যেমন ধরা যাক, আমরা এক্সাম্পলটা নিচ্ছি, this is tertiary butyl bromide. And now it undergoes a reaction that is this is pure ethanol and this is aqueous ethanol. That means water ethanol mixture. The one is pure ethanol and another is aqueous ethanol, ethanol water mixture. Both are giving the same product. Here the reaction rate, it is found R1 and it is say reaction rate is R2. Now the question is that it has been found that R2 is much greater than R1 and explain the fact. One more thing it is given, now দেওয়া থাকতে পারে, তো আমি বলে দিচ্ছি, the mechanism proceeds through SN1. Mechanism proceeds through SN1. Then it has been observed that this R2 is much greater than, there's a reaction rate of this second one is much higher than that the first one. Explain the fact. What is the explanation? Explanation is based on the solvent effect. So as we know, SN1 is highly favored in that is the highly polar protic solvent. SN1 is favored in highly polar protic solvent. So here in this case, this protic solvent, the hydrogen bonding ability is less in pure ethanol, is much more in aqueous ethanol. Dipole moment also is much higher in aqueous ethanol rather than ethanol. So so far as polar protic solvent is concerned, this is much better solvent than this one, so far as SN1 mechanism is considered. So this one is much better solvent than this one for SN1 mechanism. So naturally, SN1 always proceeds much faster using this solvent. And here the polarity is less. Not only that, the protic solvent, there is a hydrogen bonding capability is also less. And that's why the reaction rate using this solvent is comparatively less. বোঝা গেল? Answer is clear. আচ্ছা সিমিলার টাইপ আরেকটা দেখা যাক say this one Cn minus plus CH3I Cn minus plus CH3I it will give this is CH3Cn. This is also CH3Cn, and here the solvent is ethanol, and here the solvent is DMF. Here the reaction rate is R1, here the reaction rate is R2, and here also has been found R2 has been found much higher than R1. Explain the fact. So এখানেও আমাদের the answer will be based on the effect of solvent. So you can see this is primary halide. Primary halide means this is SN2 mechanism. এটা বলে দেওয়া থাকতেও পারে নাও থাকতে পারে, but primary halide without any steric strain, that means it follows SN2 mechanism in general. So SN2 mechanism, as we have seen earlier, it is usually favored in presence of aprotic solvent. This is protic solvent, this is aprotic solvent. Naturally, SN2 mechanism is favored in presence of DMF, so with higher reaction rate. And in presence of ethanol, reaction rate is decreased because there's the base is Cn minus nucleophilic, there's nucleophile is Cn minus, its nucleophilic character is sufficiently reduced due to hydrogen bonding that is happening in presence of ETOH, and that's why reaction rate is low. Here reaction rate is high. Okay? This is one type of reaction. Then comes to আচ্ছা এই পর্যন্ত থাক, তারপরে আমরা SNI টা দেখে নিই আগে, তারপরে দেখা যাবে। আচ্ছা SNI mechanism এ দেখো point wise. Number one, in some SN reactions, neighboring group takes part in mechanism to form the product. Neighboring group takes part in mechanism to form the product. This is point number one. This is point number one. Second point, neighboring group acts as nucleophile. Neighboring group acts as nucleophile to form stable carbocation. And number three,
sir, stable carbocation হলে তো SN1 বলবো না স্যার?
হ্যাঁ, এবার আমি বলছি কেন SN1 হচ্ছে না, কি হচ্ছে না তুমি দেখলেই বুঝতে পারবে। নাম্বার 3, cyclized carbocation is formed like this. This is nucleophile or something like that. Neighboring group. NG করে দিলাম, NG neighboring group. Cyclized carbocation, NG. Cyclized carbocation is formed in the transition state. Cyclized carbocation is formed in the transition state and it is highly stable. It is highly stable instead of single carbocation. Single carbocation থেকে cyclized carbocation, because charge is delocalized, it is highly stable, and that's why reaction rate is very fast. reaction rate is very fast. ঠিক আছে? Number 4, SN1 SN2 কেন হচ্ছে না আমরা এক্সাম্পল দিয়ে সবকিছু দিয়ে আমরা দেখিয়ে দেবো। Number 4 এ লেখো in some reactions mechanism follows SN1.
Sir, in some reactions.
Mechanism follows SN1. মানে SN1 এর মতন বিহেভ করছে। That means that is first order reaction kinetics. So mechanism follows SN1, that is first order reaction kinetics. But only one product is formed. That is against opposite the behavior of SN1. SN1 a multiple products are formed, but it looks like SN1, but only one product is formed. একটাই product দিচ্ছে। And number 5, সবগুলোরই আমরা এক্সাম্পল দিয়ে দেবো, আমরা আগে দেখে নিই। Number 5, in some reactions mechanism follows SN2. That means reaction rate is second order. Reaction rate is second order kinetics. ঠিক আছে? So in some cases, in some reactions, mechanism follows SN2, but the product is formed with retention of configuration. এখানে যেমন inversion of configuration হয় in SN2, already I have shown in 2 examples. In SN2 always inversion of configuration is observed, but here it looks like SN2, but the product is formed with retention of configuration. And that's why the total overall mechanism lies in between SN1 and SN2. কোনোটাই নয়। That's why it is called SNI, intermediate. এবার আমি একটা এক্সাম্পল
Optically active.
Optically same optical activity. যদি কম্পাউন্ড অপটিক্যালি অ্যাক্টিভ হয়, product will be also optically active with the same direction, that is clockwise direction. প্লাস হলে প্লাস হবে, মাইনাস হলে মাইনাস হবে। ঠিক আছে? যেটা অপোজিট, that is not the characteristics of SN2. আচ্ছা, এবার দেখা যাক, আমি একটা করে একটা এক্সাম্পল দিচ্ছি। একটা যেটা SN2 সিম্পল এক্সাম্পল is this, say এইখানে লিখি CH2 Br and now this is bromine is liberated, but instead of forming carbocation, this lone pair is given to this carbon, forming the cyclized cation. Cyclized cation with the formation of the leaving group, that is leaving group is separated. Cyclized cation is not the simple carbocation like SN1. Cyclized carbocation. This is called SNI mechanism. Reaction rate, that's why it is very fast. Because it is highly stable rather than simple carbocation. Here also you can see this is primary halide, but instead of following SN2, it follows SNI because of this highly stable carbocation. বুঝলে ব্যাপারটা? এটা কিন্তু SN2 ফলো করে না, due to the interference of neighboring group participation এর জন্য এটা it will follow SNI rather than SN2. আচ্ছা, এবার দেখা যাক, এবারে আমি অপটিক্যালি অ্যাক্টিভ কম্পাউন্ড একটু নিয়ে একটু দেখিয়ে দিই। For example, say this one. Say this is bromine. So this is optically active compound. For example, plus optically active compound. Now, bromine, that is living group, when this living group is departed, this O minus, that is supporting this carbon atom. So it will form like this. This is C O, and this is C double bond O, and this is R1. And then this is this in presence of, say, OH. In presence of OH, then it will form with retention of configuration. This is OH. The only one product is formed. There is no other product. That is, this is SN1. This looks like SN1 বলবো না, এটাকে আমরা বলবো first order kinetics. It follows first order kinetics like SN1, but the product is different from SN1. It should be racemic mixture, optically active compound, as we have seen. An optically active compound, when undergoes SN1, a racemic mixture is formed. Racemic mixture is formed. But here there is no racemic mixture. Product is also optical activity. এখানে plus হলে this is also plus, because in both the cases H on the left hand side. ঠিক আছে? This is one example where it follows first order kinetics. Now I'm taking another example where it follows second order kinetics, but similar type of product is obtained. Say this one. So this is optically active compound, and here it is treated with ionyl chloride. This is second order kinetics. This is the slowest step. And what will happen? This HCl is liberated first. আমি এইখানটা একটু বড় করে আঁকি। And this is R, and this is methyl group, and HCl is liberated. So this is the intermediate transition state. Second order kinetics. Now, what is happening? This is the neighboring group. Now, in the transition state, this is the neighboring group. Transition state. This is the neighboring group, and this then attacks this carbon atom, and এটা বেরিয়ে যাচ্ছে as SO2, and forming the retention of configuration, product with retention of configuration. So if it is plus, this is also plus, retention of configuration. So it looks like SN2 because it is following second order kinetics, but actually retention of configuration is observed at the end of the reaction with the same optical behavior. This is our SNI mechanism. বুঝা গেল? Is it clear? SNI? আচ্ছা, এইবারে আমরা এখানে আচ্ছা, স্যার কি কতগুলো কোশ্চেন করিয়েছিলেন এই রেজোনেন্স বা এগুলোর উপরে? কোশ্চেন কিছু ডিল করেছিলেন? যে অ্যাসিড স্ট্রেংথের উপরে বা বেসিক স্ট্রেংথের উপরে, যে হুইচ ওয়ান ইজ মোর অ্যাসিডিক, এগুলো কিছু বলেছিলেন? হ্যাঁ,
অল্প কটা করিয়েছিল স্যার।
অল্প কটা করিয়েছিলেন না? ঠিক আছে। আচ্ছা, যেমন ধরে যাক আমরা এইটা দেখিনি, দেখো এটা করিয়েছেন কিনা। আমরা দুই একটা করে নিয়ে আজকে ক্লাসটা এ করে দেবো। SNI পর্যন্ত হয়ে গেল। সো নেক্সট ডে এলিমিনেশন রিঅ্যাকশনসটা হবে আর কি। যেমন ধরো এইটা স্যার করেছেন কিনা দেখো, ক্যান ইউ whether you can recall? Which one is more acidic and why? এটা করেছিলেন কি? Which one is more acidic and why? So যদি করিয়ে থাকেনও আমি একটুখানি বলে দিই, একটু রিকল করে নিই। This is salicylic acid, that is O-hydroxy benzoic acid, known as commercially known as salicylic acid. And this is p-hydroxy benzoic acid. P-hydroxy benzoic acid. So acid strength depends on this factor. For example, let's say this is an acid, say H plus and A minus. This is called conjugate acid, and this is called conjugate base. Now, acid strength depends on stability of conjugate base. If the conjugate base is highly stable, that means forward reaction is favored, acid is stronger. That is conjugate acid is strong. Conjugate base stable money, it is a weak base. Whenever conjugate base is stable, it is a weak base, and corresponding conjugate acid is strong because forward reaction is favored. Or এরকম যদি হয়, conjugate base is unstable, that means conjugate base is strong, then reverse reaction is favored, backward reaction is favored, so corresponding acid is weak. That is the principle of acid strength or basic strength. Conjugate base তখনই strong হবে যখন corresponding acid is weak, আর conjugate acid তখনই strong হবে যখন corresponding base is weak. So let's see, here also the similar principle is applied to answer these questions. So here you can see this is C=O minus, and this is H. And here in this case, C=O minus, OH plus H plus. So naturally, in case of salicylic acid, conjugate base is stabilized through intramolecular hydrogen bonding. It is stabilized through intramolecular hydrogen bonding, and hence, as it is conjugate base is stable, corresponding acid is strong acid. ঠিক আছে? So conjugate base is stabilized through intramolecular hydrogen bonding. So conjugate base is stable and weak. So corresponding acid is strong. And here there is no such stability of conjugate base. So conjugate base is relatively unstable compared to this one. Relatively unstable. So conjugate acid, that means this one, p-hydroxy benzoic acid, is weaker than this one. This is a stronger acid. বুঝে গেল? So this is an example of how hydrogen bonding influences the acid strength or basic strength. আচ্ছা, আমরা ক্লাসটা এখানে কমপ্লিট করি। আচ্ছা, রোল নাম্বার 64,
Present, sir.
65,
Present, sir.
কারা কারা যেন হোম অ্যাসাইনমেন্ট দাওনি, জমা দিয়ে দিও। কজনা যেন বাকি আছে, 3 জন না 4 জন। আচ্ছা, 66,
Present, sir.
67,
Present, sir.
68,
Present, sir.
69,
Present, sir.
70, 71,
Present, sir.
72,
Present, sir.
73,
Present, sir.
74,
Present, sir.
75,
Present, sir.
76,
প্রেজেন্ট স্যার
77,
Yes, sir.
78,
প্রেজেন্ট স্যার
79,
Present, sir.
80,
Present, sir.
81,
Present, sir.
82,
Present, sir.
83, 84,
ইয়েস স্যার
85,
Present, sir.
86,
Present, sir.
87,
Yes, sir.
88,
Present, sir.
89,
Present, sir.
90, 91,
Present, sir.
92.
Present, sir.
ও আচ্ছা, তোমাদের একটা জিনিস বলে নি, 92 অব্দি হলো, একটা জিনিস বলে নি তোমাদের
present 92
এই- হ্যাঁ
92 present.
হ্যাঁ হ্যাঁ, ওই পর্যন্ত হয়েছে। আচ্ছা, আমি বলছি যে তোমাদের এমএআর এর সার্টিফিকেটস তোমরা ওই ফার্স্ট সেমিস্টারেও করেছিলে, টোটাল 1 বছরেরটা কিন্তু তোমরা রেডি করে রাখবে ওই রকম ভাবে। এমএআর এবং মুকসের যখন নোটিশ দেবে তোমরা যেন দেরি করবে না, ইমিডিয়েটলি ওটা কিন্তু তোমরা আপলোড করে দেবে তোমাদের যে এইগুলো ডকুমেন্টস গুলো, ঠিক আছে?
Okay, sir.
এটা বলে রাখলাম আর কি, কারণ তখন দেরি করলে কিন্তু মুশকিল হয়ে যাবে। মার্কস হ্যাঁ 1 বছরেরটা রেডি করে, 1 বছরের
Yes, sir.
1 ইয়ার।
স্যার
স্যার
হ্যাঁ।
ফার্স্ট সেমে যেগুলো আপলোড করেছিলাম ওগুলো আবার আপলোড করতে হবে?
হ্যাঁ হ্যাঁ, ওগুলো আরেকবার করতে হবে, ঠিক আছে? 1 বছর তখন নেয়নি, 1 বছরেরটা নেবে আর কি, ঠিক আছে? সুতরাং টোটাল 1 ইয়ারে যত ডকুমেন্টস আছে তোমরা রেডি করে, একদম রেডি করে রেখে দেবে, যখনই বলবে তখনই আপলোড করবে, দেরি করবে না, একদিনও দেরি করবে না, উইদিন 24 আওয়ার্স। হ্যাঁ, জাস্ট এ মিনিট। একটু পরে ক্লাসে আছে। সুতরাং ডোন্ট ডিলে ইন সাবমিশন, এটা হচ্ছে আমার বক্তব্য। তাহলে পরে তোমাদের যেমন মুশকিল হবে, আমাদেরও সেরকম ইকুয়ালি উই উইল বি ইন ট্রাবল। হ্যাঁ, কি মার্কস পাঠাবো, জমা দেয়নি, এটসেট্রা এটসেট্রা। আচ্ছা, 93,
Sir, 93 নেট চলে গেছে তাই বললো।
আচ্ছা ঠিক আছে, ওকে, নো প্রবলেম। 94,
প্রেজেন্ট স্যার
95,